Welcome back to Applied Algebra and Trigonometry. We're going to be talking about the double angle formulas of trigonometry today. Okay, let's find the sine of 120 degrees. Using the sum and difference formulas, we could rewrite this as 180 degrees minus 60 degrees, and we would use the difference formula for sine. Or we could do the sine of 90 degrees plus 30 degrees and use the sum formula for sine. But 120 is equal to other things as well. 120 is equal to 2 times 60 degrees. So we could take the sine of 2 times 60 degrees. Is there a formula for that? Yes, there is. These are called the double angle formulas. As you can see, the cosine double angle formula, the cosine of 2x, has 3 different possible values. So there they are. Double angle formulas for sine, cosine, and tangent. As you can see, cosine gets special treatment. There are 3 different ways that the cosine of 2x can be rewritten. Let's take a look at this sine of 2x though that I wrote earlier. According to the formula, that's going to be equal to 2, the 2 comes out in front in this instance, times the sine of 60 degrees times the cosine of 60 degrees. Well, how does that help us? It helps us because we know how the special triangle, the 30-60 right triangle, works. Opposite the smallest angle, we always have 1. 2 is the hypotenuse, the square root of 3 is the longer leg. So, we can evaluate this. The sine of 60 degrees, according to this triangle, is equal to the opposite, square root of 3, over the hypotenuse, 2. And the cosine of 60 degrees is equal to the adjacent side over the hypotenuse. So now we have the values that we need. The sine of 60 degrees equals the square root of 3 over 2. The cosine of 60 degrees equals 1 over 2. So the sine of 120, which is equal to the sine of 2 times 60 degrees, is equal to the square root of 3 over 2. And that was example 1. So let's try some cosine work. Let's try to find the cosine of 90 degrees. We're using double angle formulas, so the cosine of 90 degrees is equal to 2 times 45 degrees. Okay, so let's take the first cosine formula there. We have the cosine of 2 times x. X is 45 in this case. So that's equal to the cosine squared of 45 degrees minus the sine squared of 45 degrees. Okay? Well, what is the sine and what is the cosine of 45 degrees? Well, that's from a 45-45 right triangle. Sides are of the same length, and the hypotenuse is equal to the square root of 2. It's a special triangle you should memorize. So the cosine squared here would be adjacent over hypotenuse. Now, this is a very important point. Let me take a moment and point this out to you because I do not want you to make a common error that occurs when we're dealing with these cosine squared and sine squared. Now, when I went through the sine example, I said we bring that 2 out. That should have reminded you of bringing a 2 out of a logarithm. And this is true. You can bring the 2 out to the front. That is not why the 2 in the sine formula comes out in front of the entire term. Especially when you're doing things like cosine squared. When you're dealing with trig functions, it is not like the log functions. This does not equal 2 cosine of x. And by the way, it also does not equal the cosine of 2x. Those are not true. The cosine squared of x is equal to the cosine of x times the cosine of x. Just like 3 squared is equal to 3 times 3. Okay? Be careful. Do not make that error. Okay. So the sine of 45 degrees is 1 over the square root of 2. Okay, be careful. We could not leave that if we weren't going to do some more work with it. We couldn't leave that radical in the denominator. Let's finish the formula. Minus sine squared of 45 degrees. Well, the sine of 45 degrees is 1 over the square root of 2, but that is sine squared. So there we go. If you square 1 over the square root of 2, you get 1/2, and you're subtracting that 1/2 from 1/2 to get 0. Well, let's see. Is the cosine of 90 degrees 0? Yes, you can check it on your calculator. You can reason it out, but yes, that's true. Let's try the second cosine formula. All right, cosine of 90 degrees equals the cosine of 2 times 45 degrees. Let's put that into 2 times the cosine squared of x minus 1, because that's something else that the cosine of 2x is equal to. Oh, but wait, we don't have x, do we? We have 45 degrees. 45 degrees. Okay? Okay, so that is equal to 2 times 1 over the square root of 2 squared minus 1. So that is 2 over 1 times 1 over square root of 2 squared is 1/2 minus 1, so that's 1 minus 1, and that gives us 0 also. I'll leave it to you to use the final cosine equivalent. Let's do an example with tangent. I think I'm about on example 4, and I'm going to say let's find the tangent of 60 degrees, because we can verify that, just like we could verify the cosine of 90 degrees. So this is equal to the tangent of 2 times 30 degrees. Okay? According to our tangent formula, that is the same thing as 2 times the tangent of 30 degrees divided by 1 minus the tangent squared of 30 degrees. Now we need a different reference triangle. So we need a 30, 60, 90 triangle. And 1, 2, square root of 3 are the sides. So that means that we have 2 times, well, the tangent of 30 degrees. There's our 30-degree angle. That's equal to the opposite, which is 1, over the adjacent. Now, once again, for our final answer, we shouldn't have the radical in there. But let's see what happens if we just plug it in this way. We may have to adjust some things at the end. 1 minus the tangent of 30 degrees is 1 over the square root of 3, but that is the tangent squared in the denominator there. So we have 2 over the square root of 3 over 1 minus, and when you square 1 over the square root of 3, you get 1/3. A few more algebra steps here, or rather arithmetic. Okay, 1 minus 1/3 gives you 2/3. Let's get rid of that complex fraction. 2/3 times the reciprocal of the denominator equals 6 over 2 square root of 3. Okay, yes. In the end here, we are going to have to rationalize that. So let's just make some room at the bottom here for a minute. I'm going to take this 6 over 2 square root of 3. I'm going to multiply by the square root of 3 over the square root of 3, because that will give me 6 times the square root of 3 in the numerator, and in the denominator, 2 times square root of 3 times the square root of 3 is 3. And we have, oh, look at that. 2 times 3 is 6. There's a 6. Those cancel. We get the answer of the square root of 3. Now, can we check that? Yes, we can check that. How are we going to do it? Well, we're going to check it against that triangle. Is it true that the tangent of 60 degrees based upon that triangle equals the square root of 3? Well, tangent of 60 degrees would be the opposite of this angle. It would be square root of 3 over the adjacent. It checks. Square root of 3 equals square root of 3. And let's make some room. So far, I've limited my examples to special triangles, but you can find the trig functions of any angle if you know the values of other functions for that angle. So let's say, for instance, that we have previously found the cosine of theta to equal 4 over 5 in quadrant 4. Okay? And we want to find the tangent of 2 times theta. Whatever theta is, we want to find out what this other thing is. Okay, first thing you need to do, always sketch the graph. All right, so I'm going to sketch it down here. Okay, in quadrant 4, I'm looking at some angle theta, and for that angle, I have the cosine is the adjacent over the hypotenuse. So I've sketched my graph. Now, find the missing side. Well, turns out my example is a special triangle after all, because that missing side is a 3, and we have a 3, 4, 5 triangle, except this is in quadrant 4. Your y values are negative. That's a negative 3. Now what do we need to do? We need to identify the appropriate formula. So what does that mean? I'm looking for the tangent of 2 theta. Which of these formulas involves a double angle for tangent? Well, there's only one of them. Sometimes with cosine, you may have to choose among them, among the different possible formulas. For tangent, there's only one. So we have our appropriate formula. Our fourth step is to find the value, okay? The value of the needed trig ratio. And for this, what do we need? What is within the formula that we just recopied? Well, we need to know tangent of theta. So what is the tangent of theta now that I've drawn this graph? Well, the tangent of theta is the opposite, which is negative 3, over the adjacent, which is 4. Negative 3/4. And then last step, evaluate. Okay, the tangent of theta equals negative 3/4. That means this formula becomes 2 times negative 3/4 over 1 minus negative 3/4 squared. And after evaluating that, we come up with negative 24 over 7. So the tangent of 2 theta equals negative 24 over 7. How do we get that? We went through all of those steps based upon this bit of information that we were given. We weren't even given what theta is. And in fact, we still don't know what theta is. But we do know what tangent of 2 theta is, and that was our assignment. And now it is your assignment to do the homework associated with the double angle formulas. I will see you in Collaborate.